In this lecture, we will learn about the open source computer vision library, OpenCV, and how to use it to work with images in Python. Computer vision is a process by which code can understand images and videos and modify them. OpenCV is a huge open source library for computer vision, machine learning, and image processing. To begin working with OpenCV, we need to change directories to where our Python file is currently located by doing cd and then typing the path to the directory. Next, we will use a pip command to install the OpenCV library. Let's type pip install opencv-python. We need to wait for this library to fully install before we can begin working with it. Up at the top of the code, we will import the CV2 module. The OpenCV library that we just downloaded provides us this module to work with images in Python. Then we will create a variable named img and set it equal to cv2.imread and pass in the string sampleimage.png, the sample image we used for the example in the last lecture. This reads in an image. Then we will call cv2.imshow and pass in the string Pikachu as the first argument and img as the second argument. This displays the image in a GUI window. The string Pikachu is the title we want to show at the top of the window, and the second parameter is the image we want to show, which is the img variable in this case. Next, we will call the wait key function and pass in 0. Without this, the window would open and then automatically close very quickly. Finally, we will call cv2.destroyAllWindows to handle the cleanup of the GUI once the code is finished. Let's run the code. You will notice that our sampleimage.png is displayed. What if we wanted to add a border around our image? To do so, we can use OpenCV's copyMakeBorder function. Underneath where we read in the image, we will set img equal to cv2.copyMakeBorder and pass in img as the first argument, and then 10, 10, 10, and 10 for each side of the border. Finally, we will pass in cv2's border constant. When we run the code, notice that a black border of 10 pixels was added around our image. Now we are going to do something different than these other examples. We are actually going to use OpenCV to draw over the image itself. Specifically, we will draw a blue X over the entire image. First, we will type height, width, channels, and set it equal to img.shape. This will unpack the values of img.shape into these variables. So height will store the image's height, width will store the image's width, and channels will store the number of channels in the image. Next, we will set img equal to cv2.line and pass in image as the first argument. Then comes the starting point, which is 0, 0. After that comes the end point, which will be the image's width and height. After that comes the color, which will be blue. Note that here the RGB is backwards, so 255, 0, 0 is blue, whereas it would usually be red. Finally, we will pass in a thickness of 10 pixels for the line. This will draw the line from the top left corner to the bottom right corner of the image. But we still need a second line to form the blue X. We will set img equal to cv2.line and pass in img as the first argument, a tuple with width and 0. This will be the starting point that starts at an X position of the image's width and a Y position of 0. Then we will pass in a tuple with the values 0 and height. This will be the end point for the line with an X position of 0 and a Y position of height. Next, we will pass in the color blue, and finally a thickness of 10 for the line. When we run the code, notice that a blue X was drawn over our sample image, meaning that our code worked. In the next lecture, we will learn about using the NumPy and SciPy libraries for image manipulation.